Okay, I am re-recording half of my, or more than half of my lesson because I noticed that only 10 minutes of it uploaded. If you're going to watch this a bit later, please be aware that there were many problems on YouTube today. So I'm not sure what the problem is. I hope that the problem doesn't continue and it corrects itself. There were many problems on YouTube. The teachers I was talking to, all of their videos cut out like mine did, so I don't know what was happening. I left off with number 1. So let's look at I did number 2. I'm going to do number 2, 3, and number 5. Okay, so number 2, state the characteristics of this function. Well, knowing what I know about the function right now, I know a lot about the function already, and I hope that you do too. I hope you remember that. If the function is in y equals ax plus b form, right? That's the general form of a linear function. And I know that if the function is given to you in this form, the b value is the y-intercept. Okay, so I look at the function they gave me, and the function they gave me is y equals 6.28x plus 1.57. So because it's in this form, I know that this is the y-intercept. So there's already a lot that I know about this function. I also know that it's a positive leading coefficient. So if it's a positive leading coefficient, I know that the line slants up. So the line trends up to the right. Remember when we were describing our functions before, when we were talking about the quadrant system and how the function operated. So we said the function rises to the right. And I also know that if this were to be put on a system, right? I'm not sure where the intercepts are. I just did that really quickly. We would say it's in from quadrant 3 to quadrant 1. So I've already answered the sign of the leading coefficient is positive. Okay, that's part A. Part B, the slope direction. Well, this would be the answer to B, right? Rises to the right. Value of the y-intercept. So y-intercept is 1.57. That's my answer to C. So I've got A, B, C. I don't know D yet. I have to figure out what D is. This is E, right? The end behavior. And the domain and range, I know the domain and range for any linear function are, unless you're doing a word problem, it's X, ER, and Y, ER. The domain are all the possible X values, and the range is all the possible Y values. The only thing I can't tell, notice I can tell all this info, the only thing I don't know without picking my calculator up is the value of the x-intercept. So I turn my calculator on. I'm going to clean my calculator out, clear it out till I see that RAM cleared. Okay, I go to y equals. I enter my equation in 6.28 x 1.57. And I also put y2 equals 0 because I'm finding the, whoops, did the wrong one. y2 equals 0 because I'm finding the x-intercept, so I need to find the x value when the y value is equal to 0. Second trace, number 5. So y1, y2 you can't see, but it was laid on top of the x-axis. So enter, enter, enter. And when y is 0, x is negative 0.25. Okay. Negative 0.25. So I kind of did mine properly, I think. So this is the x-intercept, and this is the y-intercept. Okay? So now let's take a look at an application problem, a word problem. Okay, so I've already posted notes, but I'm going to redo this. So a hot air balloon is flying at an altitude of 1236. It begins descending at a rate of 10 meters per minute. The balloon's height from the minute it begins its descent is given by this function. This is a really important statement. T represents time, H represents height. Now remember, the calculator is going to recognize this equation only in terms of X and Y. So whatever variable is standing in for Y is the one by itself, and whatever variable is standing in for X is the one inside the equation. This gives me my new names for X and Y, right? Normally this is Y, this is X. This will now be called H, and this will be called T. And the label on this axis is the height, because that's what they told me. H represents height in meters. Okay, that's really important. You have to know what units. And T represents time in minutes. Okay. So let's see what we've got here. Sketch the graph. Okay, well, I'm going to clean my calculator out. Oops. Okay, so I cleared my calculator out, so it's nice and clean now. And I'm going to type this equation in. Now, remember, your calculator doesn't use H's and T's. You have to use H's and T's if they give it to you for the question, but your calculator is always just going to use X's and Y's, okay? So I go to Y equals, press in negative 10x. Oops. Remember your negative buttons here. 10x plus 1236 equals. Okay, now I know that this is my y-intercept. So this line is going to cross the y-axis at 1236. That tells you your windows have to be changed, right? Remember our default windows? Now, this is a quadrant 1 graph. So that means x and y both would start at 0. So I changed x-min and y-min to 0. I know that I just changed my x-min and my y-min to 0. Maybe I'll record my windows here, because that's really the most important part, to be honest, is the windows. Typing in the y equals is easy. Figuring out your windows is harder. Because this is a quadrant 1 graph, they gave me a huge hint by just drawing this here. So I know that my x-min and my y-min are 0. My y-max, it says the y-intercept is 1236, right? Or I'm picking that up because I know that this must be my y-intercept. I also know that my graph is going to fall to the right. So it's going to start at my y-intercept and drop down. Therefore, the highest that I really have to go is 1236 for a y value, but I'm going to put in 1400. Okay. So at this point, you're kind of expected to know a little bit about the equation when you're given it. You should sort of know that what your y-intercept should be. Okay. So I've got 1400 for my y-max. Let's just take a look at this graph and see what it looks like. When you get this funny jagged line, it just means that the window is too small. And I know that I'm nowhere near my x-intercept, right? In order to draw a sketch, I need a y and an x. So I'm going to have to increase my x max, right? I need way more than 10. I don't know. Let's try 100. Okay, almost, right? I'm just kind of guessing smartly. I'm going to go up to 150. There's no exact right or wrong, right? You just want to be able to see your y-intercept and your x-intercept. That's good enough for me. I'm going to leave it there. So now what I'm going to do is just sketch my graph in, what it looks like. Okay, so once again, this should be my y-intercept. I have to find my x-intercept. Let's go through the motions though. Make sure we do it. So second trace value, put a 0 in for x, and sure enough, 1236. So this is 1236. And now I got to find my x-intercept. So I have to do that in a different way, right? I have to put y2 equals 0, second trace. number 5. I'm going to move my cursor down to my x-intercept, right along the x-axis. So enter, enter, enter. When y is 0, x is 123.6. So this number is 123.6. And remember, that's minutes. All right, I think I have enough info to answer any question that they could possibly ask me. So I'm going to move my calculator out of the way. Sketch the graph, yes. What does t represent? Time in minutes. What does h represent? Height in meters. What does the h-intercept represent? Well, it represents the height where the height where the balloon started to descend. Okay, it represents the height when the balloon starts to descend, go down, right? I'm just gonna section these off. These are my new windows. Okay, what does the t-intercept represent? Well, this represents how long it took the balloon to land, right? Represents how long it took the balloon to land directions. That means, why did I only draw a portion of a line and not a full line? My calculator actually shows if I increase the windows, it would show a full line, and lines actually go on forever and ever. But I can see that this graph stopped on the axis, and that's because this is a real life application or word problem. Does the graph continue in both directions? Okay, so time and height can't be negative. Like the lowest that the balloon can go is at 0 meters. That's ground level. It can't dig deep. It can't go underneath the ground. And for this graph, the experiment or the situation starts at time 0, right? And then time just keeps ticking forward. We can't go backwards in time. So time can't be negative, height can't be negative. What is an appropriate range for the situation? The range are all the possible y values. So for this situation, the range is the height. The height can't be greater than 1236. So the height is less than or equal to 1,236 meters. So I can actually express my range in words. If you want symbols, we could say, and symbols are a little better, I would say that h is less than or equal to, that's the symbol for less than or equal to, 1,236. Okay? All right. Maybe I was going to jump to 5. Maybe I'll do 4 and 5, and I think I'll leave 6. The answers are in the back, and it's kind of a more straightforward question, but I'll do number 4, especially because we had such problems today in terms of streaming. Emil currently has $200 and spends $20 a week. So they have $200 in their bank account, but they're spending $20 each week. The function a equals 200 minus 20w describes his spending pattern. Draw the graph. Okay, remember your calculator. You're going to key your calculator in as a y equals. Instead of a equals, it'll be y equals 200 minus 20x. Okay, this is what you need for your calculator. So I'm going to once again clean my calculator up. Clear all the memories out. Okay. So when I go to my y equals menu, I see a nice clean y equals, and I'm going to type in 200 minus 20x. Okay. So now on my grid, I have to use what they gave. It's a little confusing, I know, but I have to use what they gave me on my graph. So this would be the a-axis. This is the w-axis. Let's label our axes first. Let's see. This time they don't actually tell us like they did last time. So I think they did help us. W would represent the number of weeks. And A is the amount of money he has, right? The amount of money left. Okay, draw the graph. So let's see again. Now this time, if you notice, they didn't give you to the right in the proper order. Actually, this graph in proper order, the x, the minus 20x should come first. Whoops, sorry. The 200 comes last. So this is my y-intercept, right? 200. Therefore, my windows, if I go to my windows, they're still quadrant 1. So I'm going to change x-min and y-min to 0. I always leave my x-max. It's not as important. It's your y-max that you always have to change right away to see the graph. So my y-max has to be at least 200. So I'm going to put 250 in. I don't know, just to make it. And there we go. I'm just seeing my x-intercept. So it looks like it's okay, right? I could leave it as 10. If you want to make it a little bigger, by all means, it doesn't change anything, right? Let's make it 15. Okay, you just see a little more. Okay, so once again, I have a decreasing graph, right? It's falling to the right. Oops. You guys know me and my pencils. I'm still breaking them every day. Okay. So this is what my graph looks like. I know that this should be 200, my y-intercept, but I'm going to prove it to you anyway. Sure enough, my y-intercept is 200. That represents $200, right? That's what the story said. He started with 200, and the amount in his bank account is dropping because he's spending $20 a week. Okay, so let's see. Draw the graph. What does W represent in this situation? Well, it represents the number of weeks. Maybe I'll put my answers to the side here. The number of weeks. What does the variable A? It means the amount of money left. And you can see he starts with 200 and he spends till he has 0, I suppose. What does the A represent? It represents the money he started with, right? It's the money he starts with. Sorry, they don't give me a lot of room for these answers, right? What does the W-intercept represent? Okay, well, this is the W-intercept. Now, if you read the graph properly, right, this is 0. So it's the number of weeks when his money is 0. I guess I could represent it another way. What does the W represent? Okay, I'll move down here. It represents the number of weeks it takes until he spends all of his money. Okay? And to do a proper graph, we should label the y and the x-intercepts, or the a and the w-intercept, right? Again, I can label my y and x-axes will be labeled different things depending on the story. So if you have a word problem, you're not going to be using y and x necessarily. You're going to be using the variables from the word problem. Okay, let's find the x-intercept. Put into my y2 statement, I have to put 0. Then I'm going second trace, number 5. I'll move my cursor closer. So yes, 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 enter, 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 and I get when y is 0, x is 10. Okay, well, that's a nice clean W-intercept, 10. Okay, Determine the value of W when A is 0. Explain the meaning. Well, we kind of did already, right? This would mean it takes a male 10 weeks to spend all his money. Okay. Okay, hopefully, my hope is that that you're almost getting a little bored by my explanations, and that that means you're understanding things really well. Okay. What about this one, number 5? Cost to rent a hall is given by this. Okay, so knowing what I know now, this is my y equals, and if I wrote it in proper order, this would be 5x comes first, and the 100 goes. So this is C. This is N. N represents number of party guests, so number of guests. C represents the cost in dollars. Okay, and this is 0. Okay, first thing, I'm going to clean my calculator out. Okay. Go to my y equals 5x plus 100. Now let's see if we can go to our windows. Now my windows, I'm going to put zeros in for x min and y min. I'm going to leave my x okay for now. But my y-intercept's 100. And this graph is going up. That means I'm starting at 100, right? Think about this, and going up. So I think I'm going to put a 200 in here, because this is an increasing graph, right? So all of the knowledge that you've picked up will help you decide on your windows too. Let's see what this graph looks like. Not bad. I think I'll stick with that for now. So I know this is 100 because that's my y-intercept. I can prove it to you. And there is no x-intercept, right? So I could even put a little arrow here because it's going up forever and ever. So let's do second trace value, put a 0 in. Sure enough, it's 100. All right, let's see. Draw the graph. Yes. What does the c-intercept represent? Okay, I'll just move down here. It represents, okay, what does it represent here? Let's read the situation again. So this is the cost. It cost $100 for 0 guests. So it represents the cost even if no guests show up. So how would that happen? Well, that's quite understandable, right? Even if you want to throw a party and no one shows up, you still have to pay for the rental, the number of, maybe some food, the number of guests. So it represents the cost even if no one shows up. What does the n-intercept represent? There is no n-intercept, right? There'd be no n-intercept. There is no n-intercept. So for sure there'd be one over here, but that's not part of the story, right? This only occurs in quadrant 1. Does the graph continue? No. We can't have a negative cost or a negative number of guests. What is an appropriate range? Let's see. Well, the range is $100 and onward. So I guess I could say the cost is $100 or more. Okay, that's in words. In symbols, cost is greater than or equal to 100. Okay? Now let's try this next thing. Number 6, weight on the moon is not the same as it is on Earth because of the differences in the force of gravity. The function can be used to approximate your weight on the moon. Does this function indicate you'd be heavier or lighter on the moon than the Earth? Explain. Well, let's see. The moon's weight is 1/6 of the Earth weight. Well, the equation says that moon weight is 1/6 of Earth weight. That means that you're way lighter on the moon than the Earth. Lighter on the moon. A lot lighter on the moon, right? If a person weighs 80 kilograms on Earth, how much would they weigh on the moon? I'm just going to show you something a little different too, because you're still math students, right? Now, this is a very simple equation. It doesn't even have a y-intercept. It has a y-intercept of 0. But you can also do it just using a pre-cal approach too, right, if you want. So it says, because this is such a simple equation, if a person's weight weighs 80 kilometers or kilograms on Earth, how much would the person weigh on the moon? Because this is very simple, it's just a substitution. I could say the weight on the moon is 1/6 of 80, right? So that's really easy to do in your calculator. Just go to your regular keypad. 1 / 6 times 80, and you could get 13.33 kilograms. Now, I could do this and punch this into my graphing calculator too, but with something this simple, I think I might be tempted just to do it that way. What's an appropriate domain? Okay, well, what would this graph look like? This would be the M. This would be the E, right? So this is the weight in kilograms. This is also weight in kilograms. The y-intercept is 0, right? This is positive, so it's going to kind of go up like this. That's from 0 to infinity, right? So I guess the domain, the weight on Earth. So the weight on Earth is 0 kilograms or higher. Now, I know that people can't weigh like 3 million pounds, but I think an appropriate domain could be, I'm just going to say E is greater than or equal to 0. Okay. People absolutely have to have some weight. They're not going to have negative weight, but they would be starting at 0 all the way. That would be appropriate, I suppose. Okay. All right, so I hope that things are a little better for us tomorrow in terms of streaming. I'll post this video on the web with the part 1, and I will see you all tomorrow. Hopefully, maybe some of you can ask me some questions.